Section 4.4 Counting, Permutations and Combinations. Basic counting. We will investigate ways of counting more efficiency. When we arrive at the probability scenario a bit later in this chapter, we will need to count some very large numbers, like the number of possible winning lottery tickets. To do this, we need more sophisticated ways of counting. So from the session 4.1, we learned the basic probability. Probability of the event is equal to number of ways event E can occur over total number of outcomes. For these sessions, we will learn the counting. We want to find out total number of outcomes for the probability. Let's look at the first example. A certain make of automobile is available in any of three colors, red, blue, and green. It comes with either a large or small engine. How many ways can a buyer choose a car? So you can see we do have three colors and two sizes. And then we're gonna count how many ways can the buyer choose a car. Let's try to use the diagram to write it out. So we do have a color, we do have a three color. And for each color, we do have a two engine, large and small. So you can see total, we do have 6 ways for a buyer to choose a car. If I don't draw the diagram, we could just use the number. We have a three color and then two sides. Multiply it, you're gonna get 6. So we do have 6 different ways the buyer can choose a car. And recall, this is a basic counting rule. Suppose there are m choice for the first category, n choice for the second category, and p choice for the third category, and so on. Then the total number of available choice is m times the n times the p. Okay, it's just like similar to this example. We do have 3 category. Second one, we do have 2. So 3 times 2, you're gonna get 6 here. And we call this is multiplication rule for probabilities. Example 2. Suppose at a particular restaurant, you have 8 choice for an appetizer, 11 choice for a main course, and 5 choice for dessert. If you are allowed to choose exactly one item from each category for your meal, how many different meal options do you have? So we could apply the basic counting principle, right? We do have 8 choice times 11 and then times the 5. So you should get 440. I want you guys try to do your example 3 by yourself. Check your work. Same idea, right? We do have 21 novels and 18 volumes of poetry. So just multiply it. You will have 378. Permutations. Example 4. How many different ways can the letter of the word math be rearranged to form a 4-letter code word without using one letter more than once? The first one, I do have 4 choice. I can choose either M or A or T or H. So I do have 4 different combination in here. Second one, because one of the letter is taken, so I only have 3 letters left. And then the third letters, I already taken 2 of them, so I only have 2. And then last one, that will be equal to 1. So we use the basic counting principle. I'm gonna multiply by all together. So that will be equal to 24 ways. So we do have 24 different ways to rearrange the math to form a 4-letter code word. And then you're gonna see, when I do 4 times 3 times 2 times 1, I can also revise it to 4 factorial. Look at the definition. Let n be a positive integer. Then the factorial symbol is defined as follows. N factorial means I'm gonna do n times n minus 1 times n minus 2 until you multiply 2 and then the 1. Okay, and that's why we do have a 4 factorial, means I'm gonna do 4 times 3 times 2 times 1. And keep in mind that when you have a 0 factorial, that would be also equal to 1. Okay, 1 factorial is also equal to 1. You can use the TI-84 plus calculator to find the factorial. Okay, let's try to do it together. First, we try to find 10 factorial. So we're gonna do 10 and then click on the math. And then we're gonna go to the left, the PRB. This means probability. And then we're gonna scroll down for the number 4. Enter. So you do have a 10 factorial and then enter. You're gonna get this number. Okay, you can also try the 4 factorial. Click on the 4, click on the math, go to the probability, and then I'm gonna click on the factorial, number 4, enter, which is gonna be equal to 24. Example 5. How many ways can 5 different store price be distributed among 5 people? Okay, I do have a 5 different store price. And then I do have a 5 people. Similar idea, right? The first time I can have a 5 choice. Second one, I do have a 4 and then 3 and then 2 and then 1. So this means 5 factorial. So use your calculator. Try 5 factorial. 5, math, probability, number 4, enter, which is going to be 120. Okay? Or you could write it out 5 times 4 times 3 times 2 times 1. Permutation rules. When n different items are available and all of them are selected without replacement, the number of different permutation order counts is given by NPR. Okay, we call this as the permutation rule. NPR equal to n factorial divided by n minus r factorial. And keep in mind that permutation rule means the order doesn't matter. Let's look at this example. I have a 3 letter A, B, and C. Choose 2 of them and order doesn't matter. So think about it. And how many choice do we have? I do have a 1, 2, 3. And then R means how many you want to pick. I only want to pick 2 of them. I want to choose the permutation rule because order doesn't matter. One more time, order doesn't matter means AB not equal to the BA because they have a different order. Okay, so now plug into this formula, 3P2. Okay, you can calculate it. 3 factorial means 3 times 2 times 1, which is going to be 6 on the top. 3 minus 2, which is going to be 1 factorial. So that will be equal to 6. Or you guys can use the calculator. So you're going to click on the 3. And then P, we're going to go to the math, probability. And then you're going to see number 2. That's the NPR. I choose number 2, enter. And then R will be equal to 2. Okay, 3P2, enter, which is going to be equal to 6. So if I have a 3 letter A, B, and C, and I try to pick 2 of them and rearrange it, and order doesn't matter, I do have a 6 different ways. If I try to write it out, that would be like this: AB, AC, BC, BA, CA, CB. So this is how you guys using your TI-84 calculator to find the permutation and also apply for the combination. We're gonna talk about the combination for the next slide. Example 7. 8 sprinters have made it to the Olympic finals in the 100-meter race. In how many different ways can the gold, silver, and bronze medals be awarded? So we do have 8 sprinters, and we want to see how many different ways they can be get the gold, silver, and then the bronze. So since gold, silver, and the bronze, they do have the order. Okay, getting the gold or getting the silver, that will be the difference. So we'll be using permutation. So that will be 8p3. Use your calculator. So 8, math, probability, number 2, and 3. Enter. You're gonna get 336. Example 8. In how many ways can people in a 1,000 person marathon finish first, second, and last? So think about it. We do have a 1,000 people, and then they do have a first, second, and last. So first, second, and last, they do have the order here. So we still can use the permutation. That will be 1,000 P3. Use your calculator. You should get these numbers. Or you could apply the basic counting principle. Okay, so think about it. The first one, I can have a 1,000 people. And the second one, I only have a 999. And then the last one, I only have a 998. Okay, so multiply it, you're gonna get the same answer. Example 9. How many 5-character passwords can be made using the letters A to Z if repetition of letters are allowed? What about if repetition of the letters is not allowed? What is the difference between these two scenarios? So let's try to do the first part. I do have a 5-letter using the letter A to Z, and the letters can be repeated. Okay, so the first letter, it can be A to Z, which is going to be 26 choice. Second one, I still have the 26 choice because the letters can be repeated. And then the third one, same idea, 26, and then times the fourth one, the fifth one is also 26. Use your calculator. You're gonna get this number. Okay, second questions. If the repetition of letters is not allowed, okay, it's not allowed. So we'll be using the permutation again. We do have a 26 letters, and we want to pick 5 letters, and then the order doesn't matter because this is gonna be talking about the password. Use your calculator. You're gonna get this guy. So when you compare with the scenario 1 and the scenario 2, you're gonna find out the scenario 1, we do have more different ways because the letters can be repeated. But the second one, since the letter is not repeated, so we do have a less different way compared with the scenario 1. Okay, combination. When n different items are available, but only all of them are selected without replacement, the number of different combination is found as follows. Okay, this one combination similar to the idea with the permutation. Only difference is order does not matter. Okay, so let's try to do the same example, but this time the order doesn't matter. Okay, first, let's figure out what is your n. What is your all? So I do have a 3 items, so n equal to 3, and I only want to pick 2 of them. And then order doesn't matter. Okay, so means AB, that will be equal to BA. We can't, this is only one way. And we'll be using the NCR. Formula are pretty similar. Okay, it's just like we do have a 1 more 2 factorial in here. Use your calculator, you're gonna get the answer is 3. So we do have these three choices, AB, AC, or BC. Example 11. United States Senate Appropriations Committee consists of 29 members. The Defense Subcommittee of the Appropriations Committee consists of 19 members. Disregarding party affiliation or any special seats on the subcommittee, how many different 19-member subcommittees may be chosen from among the 29 senators on the appropriation committees? Since they mentioned disregarding party affiliation or any special seats on the subcommittee, so it means the order doesn't matter. Okay, order doesn't matter. So think about it. What is your N? What is your R? And then since the order doesn't matter, we're going to use the combination. So 29 people, and then we're going to pick 19 of it. Use the calculator. So you're going to do 29, math, go to the probability, and then I'm going to choose number 3 for combination. And then 19, enter. So you're going to get this number. Probability using permutations and combination. Look at this example. A 4-digit PIN number is selected. What is the probability that there are no repeated digits? So for this example, we are looking for the probability. From the previous example, we usually looking for the total outcome or the favorable outcome. And for the probability, remember the formula? Probability of event E equal to the favorable event E can occur over total number of outcomes. So in this example, we are looking for 4-digit PIN number. Let's figure out what is the total number of outcomes first. So for each digit, we do have a 10 choice from 0 to 9. So we do have a 10 possible outcome for each numbers. For the second one, we also have a 10 different choice. Same idea with the third digit and the fourth digit. So when we multiply all together, that will be the total number of outcomes. How about the favorable event E? We do have a 10 choice and we want to pick 4-digit numbers. And since this is a PIN number, so the order doesn't matter. So we're gonna use the permutations rule. So that will be 10P4. Okay, one more time. We do have a 10 numbers here and we want to pick 4 of it. And the order doesn't matter because this is gonna be the PIN number. So the probability, that will be the favorable E, which is not gonna be this guy, over the total outcome. Use your calculator. 1 to the 3 decimal space. You should get 0.504. Example 13. Hannah told Sheldon that he would give him a big hug if he drew 3 A's and 2 5's. No particular order. What is the probability Sheldon draws this 5-card set? 1 to 3 significant digits. So let's figure out what is the favorable outcome. We want to pick 3 A's and 2 5. And there's no particular order. So you could pick an ace first and then pick a 5 and then ace and 5 again, or it doesn't matter for the order here. So you're gonna know, since there's no particular order, we can use the combination. What is probability Sheldon draw these 5 cards? So try to figure out how can they draw the ace in here. We do have a 4 ace in a 52 paying cards. So 4 A's, we want to pick 3 of them. And we're gonna use the combination. So that will be 4C3. Think about it. How about 5? We do have a 4, 5 in the paying cards, and we want to pick 2 of it. And again, that's a no particular order. So that will be 4C2. And this is gonna be your favorable outcomes. So think about it. How about the total outcomes on the denominator? Total outcomes, we do have a 52 cards, and we want to pick 5 of it. So that will be 52C5. So probability, you're gonna multiply these two favorable outcome over the total outcome. Use your calculator. Okay, let's try to do it together. So we're gonna have a 4, math, probability number 3, times 4, math, probability 2. And then divided by 52, and then 5. Okay, you're gonna get this number. Okay, you're gonna see that will be 9.23 times 10 to the power of negative 6. Okay, this is gonna be the scientific notation when you see the E. Okay, 9.23 times 10 to the power of negative 6. So this is means you're gonna move your decimal space 6 to the left. Okay, so that will be 0.000000923. And then they want you 1 to 3 significant digits, so we don't count the zeros here. Okay, or you could give me this one as your final answer. Okay, 3 significant digits. Okay, example 14. In a certain state lottery, 48 balls, number 1 through 48, are placed in a machine, and 6 of them are drawn at random. If the 6 numbers match the numbers that a player had chosen, the players win 1 million. In this lottery, the order in which the numbers are drawn doesn't matter. What is the probability of winning the $1 million prize in a single lottery ticket is purchased? 1 to 3 significant digits. So we are choosing 6 number from 48 without regard to order. Okay, so the order doesn't matter. So we'll be using the combination. And then the total combination. We can have 48 number, and then we're gonna pick 6. So 48C6 here. That will be the total outcome. And think about it, we only have a one set of the number that match for the lottery. So the probability, that will be 1 over the total combination. Okay, this one talking about they do have the 6 specific number. Okay, and then you only can match it with one way. So use your calculator. You're gonna get this number. And then, wow, 3 significant digits. So that will be 0.000000815. So the chance that you can win the lottery with the $1 million is really, really low. Example 15. In a state lottery from the previous example, if 5 of the 6 numbers drawn matching the numbers that a player has chosen, the players win a second prize of 1,000. What is probability of winning the second prize? 1 to 3 significant digits. So think about it. I still have 48 numbers, and then I need to pick 5 number that is matched to the winning number. And then another 1 number, I could pick it whatever I want, just not match with the winning number. Actually, the idea is really similar to this example. Okay, you could imagine like we do have a 5 number. We have to match to the winning numbers, and then we only have a 1 number that is from the rest of the numbers. Okay, so the idea is really similar to the example 13. Okay, let's go back to the example 15. So now we're gonna calculate it. We need to pick 5 number from the 6 winning number. Okay, we have a 6 of them, and then we want to pick 5, and then the order doesn't matter. So that would be 6C5 here. And then the 1 number, I can pick it from the west. Okay, you don't pick it from the 48, because 48 numbers, we do have a 6 number are the winners. So we're gonna do 48 minus 6, which is gonna be 42. Okay, and that 1 number, I need to pick it from this 42 number. So that will be 42C1. Okay, when you multiply it, that will be the favorable outcome. And then the total outcome, that will be the same idea. We do have a 48 number, we just need to pick 6 of them. So 48C6. So the second price of the probability will be equal to this guy. Use your calculator. You will get this. That's it.